Hello and welcome to the second video of the STM32 Cube IDE Advanced Debug features. I'm Bruno and I'll be your host for this series. Alright, so now we are finally on the Cube IDE ecosystem. This is just how the first window will actually open for you guys for the very first time. And as you can see, there are 4 major options from the get-go, which includes how to start a new project from scratch, start a new project from an existing CubeMX configuration, or import from either the True Studio or the system workbench for STM32, or the new feature available on the 1.4.0 release, which is the import from actually a cube example. So what I'm gonna do is actually I already have this one project made for this video, so I'm gonna just ignore those 4 options and I'm going to go through the file and open a project from file system. And then I'm just gonna type here the path for the project that I've created. It's meant for an F401 based on our Nucleo board, and I'll make sure that the links for that is on the video description as well, and the code is available on our GitHub page, so you guys can give a closer look to that and be actually simpler to follow through. But since I've loaded my project here, I can actually browse a little bit through the folders, and let me just start by showing the configuration for that. So it will ask me, hey, I'm gonna change the perspective so I can fit everything that is meant to be seen on the CubeMX side of it. So I'm gonna hit yes, and I can actually see the screen appearing for the CubeMX. Alright, so we are initialization the device configuration tool, and there it is. We can see how the pins were allocated. So let me just make sure you guys are aware of the system core and the sys. So I've added the debug trace asynchronous. It's the last option here. So once I do this, the SWO pin becomes enabled. So that's through this particular pin that we are gonna see all the advanced debug features. So that's one thing to keep in mind. And the other one that I added is just a simple LED here, which I gave the name of LD2 because I'm very creative with the names. And the last thing that is very important for us to keep in mind is the clock configuration. So the first thing that we actually need to make sure that we are aware is that the frequency here is known to us, because this frequency is something that we have to input in the debugger configuration to actually make sure that the output of the information of the advanced features through the SWO is actually matching with the CPU frequency. Alright, so since these 2 features are already done, I can go over and use the shortcut key to generate the project, which is Alt plus K, or I can always go through here and actually generate my code. So it will say, hey, I'm gonna change the perspective associated with that, and yes, that's something you should be doing for me, and the code is actually gonna start. So like I said, this is a project that I've already created for this video, so let me just dig into the code and explain each and every line so we are on the same page. The first thing that I added is this particular include that will allow me to at some point use the printf function. Then I've created this define here to actually allow me to use the internal trace macro cell, so I can either monitor time or just print very simple information through this. I've created 2 global variables, so one is called loop and the other one is called data. All the other parts of the code were created automatically by the cube. So those are actually things and functions that were created. I didn't have to interface. And as you guys can probably see, all the code that I added are within the user code begin and user code end brackets on the comments. That's how we can make sure that our code will not be changed by the automatically generated feature. So here I've just added the internal trace port, just changing it to value number 1 and initializing the GPIO. This is also done by default by the cube. Then I'm using the printf function saying, hey, the GPIO initialization is done, and then I change the value of the same port of the internal macro cell from 1 to 2. And then finally on our main loop, I'm just saying, hey, I'm on the main loop, and then I'm tangling a GPIO, adding a delay, and then printing again, saying, hey, I'm under this amount of number of the loop counter, incrementing my loop counter, and checking if it's higher than 100, then I just assign it to 0, add a 15 millisecond delay, and make another choice to either increment the data by 5 or decrement it by 1000. And that's pretty much the entire code. So since this one is my entire code, now I can build it. So there's a bunch of ways that we can perform this action. The easiest one is pressing Ctrl+B, or the longer version is going through the project and making a build all. So here we can see that all files are being compiled, and once that is done, I should get the 0 error, 0 warning message, which is basically the desire and dream for every programmer. And just one small thing, since the cube ID relies on GCC, the way that the low-level function of the printf works is actually through a function called _write. So we can here see through the navigation that I actually created my own write. So the printf is using the internal trace saint_char function to actually output things. So that is the way to avoid spending or using one UART for the printf function. Alright, so now that my code is done and it's compiled, I can go through the debug and configure for the very first time. So what I want to do is go through here and select debug yes, and then I can go through the STM32 application. And once I click, it's also going to say, hey, there's a newer version of the ST-Link that is attached, and it's asking if I want to update the version of the board ST-Link that I have. And I'm just going to say yes, so you guys can see the flow for that. So this window will pop up for us, and all we have to do is just open in update mode. We are going to see that the version is going to be shown to us, and the current version and the updated version. So I'm just gonna say, hey, yes, update that for me. And there we have it, it's already done. So I can just close this window here and all set. So if I go through the debug once again and go to the debug configuration, then I can actually get a glimpse of how the tabs work for me. So the first thing that we want to make sure is that under the main, the debug name is a match for the project that we are using. So I've used a very creative name again, so it's called debug. So the binary file, the ELF file, is also called debug. And for the debugger tab itself, all I have to do is make sure that I'm selecting the debug probe that I have. So in this Nucleo board that I'm using is the ST-Link GDB server. One very important thing is that if I have more than one ST-Link connected, I can always specify which one I want to use, allowing this checkbox and clicking scan, so we can see the serial number for the ST-Link that I'm using. And if I were to debug a second one, just make sure that the port number here is a different one than the default, otherwise it will conflict through the GDB server. So once this is all set and done, I have to enable the serial wire viewer to actually see the advanced features. So here I'm gonna just enable and make sure that the clock core frequency is a match to the core clock frequency that I selected on the application. As you guys recall, it's 84 megahertz, so this is already properly done. So right now, all I had to do is just hit debug, and the application will be loaded onto the MCU. So it's actually programming the MCU. And I also have the information if I want to switch the perspective from the code editing to the debug edit. Alright, so now I'm on the debug interface. We can actually see on top that the icons have changed. I have other options right now, and I'm assuming that the basics are already known to you guys. Otherwise, we do have awesome videos covering the basics for CubeID. I'm gonna leave the video in the link and on the descriptions with the links. And what I'm gonna do right now is use the live expression, which is still a basic feature but can really save some time. So I'm just gonna add those two variables here, the loop and also the data. And once I hit play, without any breakpoints or holding the CPU, I'll be able to actually see those two numbers just changing following the code instructions. So there we have it. We can see the variables changing and being updated on their own. But this is still the basic features. But even though it's a basic feature, we went through all the needed aspects of the code and the debug configuration to actually allow us to enhance and go through the advanced features that we are going to cover through individual videos from now on. And a few extra good information for us to be aware that the ID can provide are the footprint for the flash. So we do have the build analyzer and the static stack, which will get you an overview of the amount of footprint that your application is taking from Flash, from Run, or for any linker file that you added on your own. So that will be shown on the build analyzer, and the static stack analyzer will actually explode this view and tell you, hey, on this given source file, you're consuming this amount of Flash, and even further from this particular source file, you have these functions, and each one of those functions consume this other amount of Flash. So this is a value information if you ever need to optimize your code. And then we have the output for the binary. You guys saw that I was using the .elf file for the debug session, but we can actually choose to have a .bin or .x that are more usual and standardized patterns of file to actually load your product into the platform. So from our overall takeaway perspective, we went through the serial wire debug, we managed to get the basic working, we prepared the code to run the serial wire viewer, and we added that on the configuration. And now for the next videos, we are finally digging into the advanced features, which is the last step of this video tutorial. So thank you again for watching up until this point. I hope to see you on the next videos where we are actually digging through everything. And just as a general reminder, we do have the basic things being covered through another video series, and the link is on our description. So again, thank you for watching, and see you soon on the other videos.